So let's start alcohol. Alcohol, phenols, and ethers. So first of all, we are going for alcohols. No problem, Darshan. We should go for this. That will be good. One by one. Then we will go for aldehyde also. Okay. Please do respond. Because otherwise students will be, for them, it will be tough to understand. That's why they will join soon. Are you getting my point? Okay, thank you. So let's start this alcohols, phenols, and ethers. And in this, we are going for alcohols first. So since you have studied this in school, it will be easy for you to understand and you can answer me easily. So alcohols has a formula. You can see general formula for alcohol is basically ROH. And general formula of phenol is PHOH. PH stands for basically this benzene. So this will be phenol. And ether is for ROR, or it can be ROR dash. Basically, this dash represents another alkyl group. And this is basically same alkyl group, also known as symmetrical ether. This is known as symmetrical. We can call it symmetrical ethers. And this is basically asymmetrical ether. Asymmetrical ether. So you can see when O is attached with different alkyl group, this is asymmetrical and this is symmetrical. It is very easy. And we also write this AROH. This is for arene, that means benzene, and OH for alcohol. That is known as, this is phenol, this is ether, and what is this? This is alcohol. So first of all, we need to know what is the general formula that I wrote here. Now we will go for classification, which is very important. And classification, it's same as we did in haloalkanes and haloarenes. So there is the base of classification on which base we are going to classify it. So basically, first classification is on the basis of number of hydroxy group. On the basis of, the first one is on the basis of number of hydroxy group. On the basis of number of hydroxy. Now you can see basically how many OH groups are there. According to that, we can classify like C2H5OH. So this is monohydric, known as monohydric. That means only one hydroxy group. If we have two hydroxy group, that means basically dihydroxy group, dihydric group. And if we have three hydroxy group, so we can call it trihydric. Please write it and let me know when you are done with this. Ayman, am I audible to you?
Yes, sir.
So, Ayman, we just started alcohols, phenols, and ethers. And you know what is the general formula of alcohol? This is for phenol, PHOH or AROH. We can write AR is for this benzene. This is ether, ROR or ROR dash. ROR, that means alongside O, right side and left hand side. If same alkyl group are there, that means symmetrical ether, and different alkyl groups are there, that means asymmetrical ether. Now classification is just like the previous alkyl halide and aryl halide. So the first classification is basically on the basis of number of hydroxy group. That means basically OH groups, hydroxyl group. So in the first C2H5OH, one OH is there. That's why it is monohydric, dihydric, and trihydric. I think it's clear to all of you.
Yes,
Please
sir.
let me know when you are done with this. Please write it. Madhya, why do you join late? You always do this, like 10, 15 minutes, 20 minutes. You are always late. Okay, okay. No problem. Please let me know when everyone done with this. Everyone done with this?
Yes, sir.
Very good. Madhya, you are also done with this?
Yes, sir, I took the screenshot.
Very good. Now, in the same way, we can classify this phenol. Like if there is only one OH, that means monohydric. This is also monohydric. If there is two OH, that means dihydric, we can say. And then trihydric, you can easily say for trihydric. Not hydric, vitamin. Yeah, let's see. Okay. OH, OH, right. So it's very easy, like the previous one. haloalkane and haloalkane. Now, the next classification is basically compounds containing sp3 COH bond. That means basically to whichever carbon OH is attached, that must be sp3. Like if you are going to classify this, just suppose if we have CH3, CH2OH. Now if we have CH, this is OH, this is CH3, and this is CH3. And again, if this is carbon, this is OH, this is CH3, this is CH3, and this is CH3. So you can see there will be degree of alcohol. We are going to see degree of alcohol. As we studied about the degree of haloalkane, in the same way, we will define degree of alcohol. How we, can anyone tell me what is the degree of halogen here? Can anyone tell me what is the degree of halogen? This halide.
Sir, 2 degrees.
2 degree. It's very easy. 2 degree. So in the same way, what you just did, to whichever carbon is this X is connected, tell me the degree of this. This is 2 degree. That means this is 2 degree halide. In the same way, we calculate the degree of OH. That means degree of alcohol. Degree of alcohol is equal to the degree of carbon. Degree of carbon to which it is connected. To which it is connected. So in order to find the degree of this alcohol, what you need to see the degree of this carbon to which carbon alcohol is connected. So this is 1 degree. That means this is primary alcohol. This is primary alcohol. And in the same way, in order to calculate the degree of this alcohol, you need to calculate the degree of this carbon. So it is 2 degree. That means this is secondary alcohol. And in the same way, what is the degree of this alcohol? Tertiary, 3 degree. Yes or no? Please do let me know if you have any doubt in this.
No, sir, there are no doubts.
Very good. Please write. Everyone done with this?
No, sir, I'm still doing.
Darshan and Madhya, are you done with this?
No, sir, I'm writing.
Okay, please take your time. I'm waiting.
Done, sir.
Very good. Ayman,
Yes, sir, I'm done.
very good. Now see, this is the first classification for primary, secondary, and tertiary. Now, since this classification is all about sp3 carbon COH bond, to whichever to whichever carbon OH is connected, that carbon must be sp3 hybridized. And here, the first is allylic alcohols. In the same way, when we had haloalkanes, allylic halide. This is allylic alcohols. I'm going to talk about. What is alkyl? Sorry, allylic alcohols. It is basically to whichever carbon OH is connected, it must be sp3, and adjacent carbon to this carbon must be double bonded. This is allylic alcohols. Are you getting my point? You can check the hybridization of this. This must be sp3, and adjacent carbon to this carbon must be double bonded. That means sp2 hybridized. This is allylic alcohols. So can you tell me whether it is allylic alcohols or not? Can anyone tell me this is allylic alcohol or not?
Yes, sir, it is.
It is, because you can see this is basically singly bonded carbon, that means sp3, and adjacent to this carbon this is doubly bonded, so it is allylic alcohols. And you can call it, can you tell me what is the degree of this alcohol? Primary or not? This is primary. So we can have secondary also, CH2 double bond C, HC, HOH, and this is CH3. In the same way, we can have tertiary like CH3, CH3. So just mark it whether which one is primary or which one is secondary. So can anyone tell me which type of alcohol is this? Primary, secondary, tertiary?
Secondary.
Secondary. Madhya, can you tell me which degree of this alcohol is? Madhya,
Sir, is it
I'm
secondary?
this is secondary. Are you talking about this? Is this secondary? So what you need to see, Madhya, if you are going to calculate the degree of this alcohol, see the degree of carbon attached to this. And in order to calculate the degree of carbon, just see to how many carbons directly it is attached. This carbon, and this carbon. It is directly attached to 3 carbon. That means it is 3 degree. That's why it is tertiary alcohol. Because OH is connected to tertiary alcohol. Were you saying something? You just unmuted. Okay. Madhya, now tell me the degree of this alcohol.
Is it secondary?
Yes, it is secondary, right, Ayman?
Yes.
You can see to the carbon it is connected. This is 2 degrees, so it is secondary. So please write it. This is allylic alcohols, and what is allylic alcohol is very easy. To whichever carbon, OH carbon OH is attached, that must be sp3, and adjacent carbon to sp3 hybridized carbon must be doubly bonded sp2 hybridized. Simple. As simple as that. It's very easy. Please let me know when you are done with this. I'm waiting. Let me know when you are done with this.
Done, sir.
Are you done with this, Simon?
Almost, sir.
Oh, okay. This is allylic alcohols. The next topic is basically benzylic alcohols. Please let me know, Aman, when you are done with this.
Yes, sir, I'm done.
So see, what is benzylic alcohols? There will be a benzene. This is also part of sp3COH bond. So you can see this is benzene and this is CH2O. So basically, you can see that this is sp3 hybridized and adjacent to this carbon is doubly bonded. So it is benzylic alcohols. In the same way, I can write this is also benzylic alcohols. And in the same way, I can write not CH, 2O4. Okay. C, then OH, then R dash. Please arrange this or name primary, secondary, tertiary. So you know that this will be primary, this will be secondary, and this will be tertiary. Yes or no? Everyone clear with this? If you have any doubt regarding the degree of alcohol, please ask me. Anyone? Okay.
Yes, sir.
Now the next is basically this was about sp3 containing sp3 OH bond, sp3 COH bond. This is about compounds containing sp2 COH bond. That means basically doubly bonded carbon. OH is connected to doubly bonded carbon, and the first is known as basically vinylic alcohols. We call it vinylic alcohols. Vinylic alcohols. Such as example, we can take CH2 double bond CHOH. And you can also take an example like this in cyclic form. This is double bond. You can see this is doubly bonded and it is directly connected to this. This is called vinylic alcohols. So phenol can also be vinylic alcohols, like you know that it has this and this is vinylic alcohols. In the same way, we can have another type of vinylic alcohols, like this is OH and this is CH. In the same way, the classification about dihydric is vinylic alcohols, like this. Dihydric. And trihydric too, we already did that. You know that this is OH, this is OH I'm going to take, and this is OH. This is trihydric and also an example of vinylic alcohols. Okay. So basically, we don't call basically phenol. Let me make it clear. Just write up to this only, not this part. Just don't write this part because phenol is different functional group and alcohol is different functional group. I just mixed these two, which is wrong. Okay, so just write up to this vinylic alcohols like this. Okay, don't write the phenol part. I'll just separate it. of just let me erase this. Please write it. Everyone done with this?
Yes, sir.
Very good. Now we are going to talk about basically that was monohydrate, dihydrate, trihydrate is about phenols. Okay. Now see, we are going to talk about ether. As I already told you, it is of two types. One is symmetrical ether and another is asymmetrical ether. Another is asymmetrical ether. Ether. Symmetrical ether, that means on the both side of oxygen, same alkyl group, and asymmetrical ether means on the both sides of oxygen, different alkyl group. This is the difference between symmetrical and asymmetrical alkane. So please write it. Classify the following primary, secondary, and tertiary alcohols. I'm going to give you a very basic question. You can easily do this. Please let me know when you are done with ether. Everyone done with this symmetrical and asymmetrical ether? Please do this. I will be back with water. Simon,
Yes, sir.
are you done with this? You are the only left. Only.
Yes, sir. I answered this already.
Okay, I'm just going to answer it. Just tell it. This is primary. This is
Yes, sir.
primary. This is primary. This is tertiary. This is secondary. And this is secondary. All correct.
Yes, sir.
Very good. Now, we are going for nomenclature. Nomenclature. You see, can you name it? If I'm going to give you CH3 H, then I'm going to give you H. Then I'm going to give you OH. And then I'm going to give you OH. OH. Can you name all this?
So the first one is methanol.
Methanol. Methane one, all that means methanol. What about the second one? Just do it.
Uh, Second one is propanol.
Propane. Do you know what does this means? Propane. How many carbon? Prop means
So-
how many carbons?
So 3.
3. And how many carbons present in this? 1, 2,
Okay. 4.
4. So are you numbering from left to left or right?
So right. I'm right.
Right, because we are giving functional group placer number. So its name will be butane to all. Yes or no?
Yes, sir.
Okay. The next part.
So 1,4-butanol.
Is it? Does this compound have 4 carbons or 2 carbons? This is carbon, this is carbon, this is OH now. This is
Okay,
directly
okay.
attached to OH. So
Okay,
its
sir.
name will be ethane 1,2 diol.
Okay.
1, 2.
Sure.
And do you know what its common name?
No, sir.
Glycol, also known as glycol. Ethylene glycol. And we simply call it glycol. Please name this.
Sir, prop.
Propane,
What?
because all are singly
Propane.
bonded.
Yes, sir.
Propane,
Yeah.
propane,
1, 2, 3
1,
triol.
2, 3 triol. And do you know what's its common name, which is very famous? Glycerol. It's glycerol. Please name this. And also this. And also this.
Sir, give me 2 minutes, sir. I have to
Okay.
go and come back, sir.
Okay. Madiha, did you solve that question, primary, secondary, tertiary? This question. Please let me know and just tally your answer. This is primary, this is primary, this is primary, this is secondary, this is secondary, this is tertiary.
Yes, sir, I'm back.
Very good. Madiha, are you there? So,
Yes, sir.
nomenclature of this compound. Are you done with this, Ayman?
No, sir. I've transferred those last three.
Okay. Madiha, can you name it? This compound. So we need to give the numbering. If you are going from left, functional group will get third position. And as you know that we give preference to functional group. So in order to give preference to functional group, This will be 1, 2, 3, 4. And the name will be 3, 3 dimethyl. And how many carbons in parent chain? 4, but all are singly bonded butane, 2 all. Please do the name of this and this. So see, this is cyclohexane. So we are going to give number it to 1. So it will be cyclohexanol or hexane 1-ol. Now the next naming will be 1, 2. We do numbering first and give preference to functional group. So its name will be 2-methyl cyclopentanol, pentane 1-ol or pentanol. Got it, everyone?
Yes, sir.
Can I move to the next part? Ayman?
Yes, sir.
No. Now we are going to do the nomenclature of this phenol. So please write the nomenclature of this phenol. And if you don't know how to do it, please let me know. Are you done with the first name? Basically phenol was initially a common name, but now it is treated as IUPAC. Initially, the IUPAC name of this is benzene 1-ol benzenol, but commonly called phenol, which is now classified as IUPAC. So phenol is a common name and IUPAC name also. What is the name of this? 1, 2. So this is basically 2-methyl phenol. 2-methyl phenol. In the same way, 1, 2, 3. So what will be its name? 3-methyl phenol. 3-methyl phenol. Can you name the last one? Any one of you? Ayman and Madiha, what is the IUPAC name of this compound?
So 4
4
methylphenol.
phenol.
Yes, 4-methyl phenol. 4-methyl phenol. Now come to this. It has two OH group. So its name will be 1, 2. See, its name will be basically benzene 1, 2 diol. What its name will be 1, 2, 3. Basically its name will be benzene 1, 3 diol. Can you name this compound? Benzene 1, 4 diol. Please write it. Let me know when you are done with this, please.
Thumbs up.
Very good. Are you done with this? Ayman? Ayman, can I change the slide?
Yes, sir, I'm done.
Okay. Now see how to do the nomenclature of ether. Just suppose its name is basically alkoxyalkane. This is how we are gonna name its IUPAC name. Alkoxyalkane. That means if you got CH3O CH3, this part alk is for basically substituent or branch. When we treat one of the alkyl group as substituent or branch, and this alkane is for parent chain. This alkane is for parent chain. And the same rule, One which has more number of carbon is the parent chain, and one which has lesser number of carbon is substituent. So you can see both have the same number of carbon, so anyone you can treat. So just take this as substituent. How many carbon? One, so it will be meth, and oxy from the iutate, so it will be methoxy. And now this is the parent chain. How many carbon? Meth, and singly bonded, so it will be methoxy methane. The name will be methoxy methane. Is that clear to everyone? Now see, if we have CH3CH2 and this is OCH2, so you can see that this has two number of carbon and this has one number, this side one number of carbon. That means this will be treated as substituent and this will be treated as parent chain. Parent chain. So substituent, that means how many carbon? One carbon meth, methoxy, and this is two carbon eth and singly bonded, so it will be eth. Is that clear to everyone? Now you can see how many number of carbon? Three carbons here, two carbons here. So this will be substituent. So eth, two number of carbon, oxy, and three number of carbon, prop, and singly bonded ethoxy prop. Is that clear? Both of you done with this? Ayman?
Yes, sir. Done.
Very good. Now I'm going to give you some question on this. Please do this. See, I'm going to explain. Did you write the name of the first compound? So you can see 2 carbon on both sides. So 2
Yes, sir.
carbon, that means ethoxy. Anyone you can take as substituent and parent chain, ethoxy ethane. Yes or no?
Okay, sir.
Now see, this has 1 carbon, this has 6 carbon. This is benzene basically. So basically it will be methoxy and then benzene. Are you getting my point?
Okay.
Now see this one. So this has 1, 2, 3 carbon and this has only 1 carbon on the left hand side. So this will be the parent chain. So its name will be 2-methoxy because the branch is on 3rd carbon connected to 3rd carbon, 2-methoxy propane. Is that clear to you?
Yes, sir.
So please write, and the rest of the question you are going to do it from home. That means 2 questions only. You can tell me right now what is the name of this compound.
So ethoxybenzene.
Very good. So its name will be ethoxybenzene. In the same way, you can name this 1, 2, 3, 4, 5. So 3-ethoxy pentane. Yes
sir.
or no?
Yes.
So from here we will continue in the next class, basically alcohols and phenols structures and then preparation of alcohols. Okay.
Okay, sir. Thank you.
Okay. Thank you. Do you have any doubt?
No, sir. No.
Okay. Thank you.